Hi everyone, in this video we are going to discuss the first law of thermodynamics. So first of all, we're not going to go super deep into thermodynamics into this course. You should be very grateful for that because it is quite a complex subject. But we are just going to talk about little pieces of thermo, which is thermodynamics for short, and we're going to start off by looking at the first law. So the first law sounds a lot more complicated than it actually is, and really it just says that energy cannot be created or destroyed. So if you ever say to me, oh, well, this created energy, I'm going to correct you right away because we cannot create energy. We either absorb it or we release it. So in other words, what we're really saying with the first law is that energy is transferred. It is not created, it is not destroyed, it is literally moved from one object to a next and back and forth and back and forth. So the easiest way to show the first law of thermodynamics is with an example showing the differences of energy from photosynthesis and combustion. So let's go down here a little bit and draw out a little map. So let's start off by putting photosynthesis on this side. And then we're going to put combustion on the other side. So essentially what we know is in order to have a combustion reaction, we take a source of fuel, treat it with oxygen, and we produce carbon dioxide and water. Whereas photosynthesis is the opposite. They take carbon dioxide and water and create glucose, or a source of fuel, and oxygen. So let's start off with this. Our fuel, so we're going to say is our glucose, so C6H12O6, plus oxygen. When we put that together, we have a combustion reaction. And so what happens is we create and then release carbon dioxide and water. So we said combustion is an exothermic reaction. It releases energy. We take glucose, oxygen, it burns spontaneously, it naturally happens. We create carbon dioxide and water with a release of energy. It is an exothermic process. Now, the opposite of that would be photosynthesis, where they take carbon dioxide and water. They take some energy in order to do this. So this would be considered an endothermic process. You must add energy in order to force carbon dioxide and water to convert into something. Because we have carbon dioxide and water right here in my office, right here in my atmosphere, and it is not spontaneously making glucose. That's not happening. We absolutely need energy, and we actually need chlorophyll as well to go through this process. So we have carbon dioxide and water, we add energy, and we convert them into our source of fuel and our oxygen. So essentially up here, this needs to gain energy in order to happen, whereas this bottom one releases energy. Okay? So now my question for you would be, knowing that photosynthesis is an endothermic process. Which sometimes you will hear me refer to it as endo, okay? From where does the incoming energy come? From where? Go. Did you get an answer? Hopefully you did, and hopefully this was really easy for you, but if not, we're just reviewing. Photosynthesis needs the sun. The energy comes from the sun. So essentially what we're seeing is we have an increase of energy here. We take carbon dioxide and water plus energy. We convert it to glucose and oxygen. Now, when we set that on fire, we are releasing that same amount of energy, and we're going back through and creating carbon dioxide and water. So if I wanted to, I could actually draw an energy scale on here and have high energy up here and low energy at the bottom. Okay? So essentially what we can see from this is the first law of thermodynamics stays true. We're not creating energy, we're not destroying energy, we are only transferring it. So we're transferring it from glucose and oxygen to carbon dioxide and water, and we're just transferring in this beautiful cycle. You cannot create, you cannot destroy energy, you can only transfer it. Bye guys, drink water.